These are a couple of TSOP1738 infrared receiver sensors. Even though this seems to have only 3 pins, this is not a simple 3-pin transistor. It is actually an integrated circuit inside which has a receiver for infrared. A sensor is there and the processing is done and the output is given out through this lead. The other lead on the opposite side is a ground terminal and the supply voltage is given in the central one. That is 5 volt is the supply voltage. We can go up to 6 volts maximum, but 5 volts is the ideal. So I am planning to use a USB power supply for this so that it will give around 5 volts. I am using a simple USB power supply. This is a USB power supply which you often use for charging a mobile phone, and I have taken a USB cable out of it, and this is the USB cable here. You can see that I have stripped one end of the cable so that 2 wires are left alone. The green one and white one, these are meant for data transfer in USB cables, so I don't need that for this experiment. I am using a couple of crocodile clips to connect the red wire and the black wire. These are the 2 ones which carry the power from a USB outlet. And you can see that the measurement is being done here in the digital multimeter. It is 5.44 volts. A little more than 5 volts is there. TSOP1738 infrared receiver sensor needs a power supply between 5 to 6 volts. So this is acceptable for me. Alternatively, I could also use a power bank. I need a 1 kilo ohm resistor for the circuit, and I am testing the resistance of that resistor with a digital multimeter. You can see that I have selected the 2 kilo ohm option, 2000 ohms option over here, and I have connected the leads across the resistor, and it is reading as 987. That is acceptable for a resistor with 1 kilo ohm resistance, because this is shown as a 5% tolerance resistor. The bands seen here are, the last band is golden, meaning that it is a 5% tolerance resistor. The first band in this resistor is brown, indicating digit 1. Second is black, indicating digit 0, so 1 0. Then the multiplier red means you have to multiply by 100. So 10 into 100, or rather 10 to the power of 2, you will get 1 kilo ohm resistor or 1000 ohm resistor with the golden band showing 5% tolerance. Now I am testing the LED. You need a green LED for the circuit, and that is being tested. For that I have to choose the option of LED testing here. This is the LED testing option in this multimeter, digital multimeter, and you can see that LED has been lit up green. So this is testing the green LED needed for the circuit. Now I have assembled the testing circuit for checking the infrared receiver TSOP1738. This is the supply voltage, and it is the same supply voltage which will go to the anode of the green LED needed for testing. And green LED is connected to the output of the TSOP1738 using a 1 kilo ohm resistor. That is, the cathode of the green LED will connect to the output of the TSOP1738. And this is the ground supply for the TSOP1738. And these two are the terminals which I will connect to the power supply which I had shown earlier, USB power supply. Now I have connected the USB power supply to the circuit on the breadboard. You can see that the breadboard is there with the circuit. Now I'll use the home infrared remote. You can see that when I am pressing the infrared remote power button, momentarily the LED lights up. Whichever button I press on the remote, LED lights up. That is because a signal is being sent from the infrared remote to the infrared sensor, and that is a signal on an RF frequency that is 38 kilohertz. 1738 receives at TSOP 1738 receives at 38 kilohertz. Actually, it is not the frequency of the infrared light, that is much higher, and the modulation of the 38 kilohertz frequency is being done by the infrared remote control, and demodulation is being done by the sensor, so that you get an output. For various type of signals sent out by the infrared remote, there will be different coding. Now I am using the same setup with a power bank instead of the USB power supply, and instead of the TV remote I am using an AC remote. See, it works. The test circuit works for AC remote and power supply. Instead of the USB adapter, I am using USB power bank. Now I am using a different type of LED, that is an orange LED. You can see that it works with orange LED also. This is red LED. Red LED is also working. Now it's a different color LED. This is actually a multicolor blinking LED, but as only one signal is being sent out, it works only in one color. If it is switched on continuously, it will blink in different colors.